Alright guys, so let's tackle the part 2 questions right now, and then we'll be done. Then you guys should have enough material to study for and do excellent on Thursday's test. So, question 25. Alright, now these are all constant acceleration questions, right, which means that they're using one of those three equations on your reference table. Let's look here. We need to show all variables, list the equation used, show all work, and round to the nearest tenth. So, Astrid the astronaut is standing on the surface of a distant planet which has an acceleration due to gravity of 4.5 meters per second squared. She drops a rock from her hand, and it took 2.6 seconds for that rock to land. Find the final velocity of the rock. So I'm going to use the word method here, and I'm going to list all of my variables first so there's no confusion. So VI, VF, A, D, and T. And then let's figure out which variables I've been given here. So he is standing on a planet which has an acceleration due to gravity of 4.5 meters per second squared. So that's my acceleration. All right. She dropped a rock from her hand. Now, anytime somebody drops something, its initial velocity is starting off as 0. All right. It took 2.6 seconds to land, so that's our time. And find the final velocity, so that's our unknown. That's what we're looking for. So in this question, we're not given D. So do we have an equation that deals with VI, VF, A, and T? That's VF equals VI plus AT. And we just need to plug in here. So VF is our unknown. VI was 0 plus A, which was 4.5, and times T, which was 2.6. Alright, so in the end, VF is just going to be equal to 4.5 times 2.6, which is going to be 2.6, 11.7. No rounding necessary. And now this is meters per second, since it's a velocity. Final answer. Units and everything. So let's look at number 26. An airplane accelerates down a runway at 5.6 meters per second squared for 24.3 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So, using that word method, I'm going to list all my variables. VI, VF, A, D, and T. Alright, now let's figure out which ones I've been given. So in this question, airplane accelerates down a runway. So our acceleration is that 5.6 meters per second squared for 24.3 seconds. So that's got to be our time, 24.3 seconds until it finally lifts off the ground. So if something is accelerating down a runway, it had to have started at 0. So that's our initial. And in the end, determine the distance. So distance is our unknown. That's what we're looking for. So in this question, we weren't given a VF. Cross that one out. So which equation deals with an initial, an acceleration, a distance, and a time? It's going to be our D equals VIT plus 1/2 AT squared. All right, let's plug in. Distance is unknown. Initial was 0. Time was 24.3 plus 1/2 of A, which was 5.6. Times T squared, so that's times 24.3 squared. 0 times anything is 0, plus this I'm all just going to punch right into my calculator. So 1/2 times 5.6 times 24.3, which I'm squaring, is going to give me 1,653.4. That's if I round it. So in the end, my distance is equal to 1,653.4, and that's distance, so it's meters. Alright, so we're on number 27. Let's grab some red here. So, a bullet leaves a rifle with a muzzle velocity of 521 meters per second While accelerating through the barrel of the rifle, the bullet moves a distance of 0.84 meters. Determine the acceleration of the bullet. Assume that it's constant. So in this case, we're just assuming constant acceleration, which is fine because these are all the constant acceleration questions. So I'm going to list my variables, VI, VF, A, D, and T, see which ones I've been given. So a bullet's leaving a rifle with a muzzle velocity. So if I drew a picture of this, here is the barrel of the rifle. This is the end, alright, so this is its muzzle, and we have a bullet that's kind of firing out of this thing. And we want to determine the acceleration that happened throughout the barrel. So this is going to be our final. When it leaves the barrel, that's going to be its final velocity. So that's that 521 meters per second. Now if the bullet was fired, then it must have started at rest. If it started at rest, its initial is 0 meters per second. They want us to determine the acceleration, so that's going to be our unknown. And they've given us that the barrel is a distance of 0.840 meters. So in this case, we weren't given time. So let's figure out which equation deals with these four variables. And that's our VF squared equals VI squared plus 2 times A times D. VF was 521. The VI was 0. Plus 2 times A, which is unknown, times D, which is 0.84. So 521 squared, that's going to be 27,1441. 0 squared is 0. 2 times A times 0.84 is going to give me 1.68A. Alright, now I need to get A by itself. So in order to get A by itself, right, because this 0 just drops out, I need to divide each side by 1.68. And then that way that'll cancel. Divide this side by 1.68. It's kind of sloppy. And in the end, I'm going to get 271,441 divided by 1.68. It's going to give me an answer of 161,572.0, and that's equal to A. And this is an acceleration, so this is meters per second squared. So this is how fast the bullet is accelerating through the barrel of a gun, and this kind of makes sense because bullets are really fast. So let's do this last question. So there's a couple ways to do this one. Alright, standard issue, I'm going to start off, list out all my variables, VI, VF, A, D, and T. Figure out what I've been given here. So Mr. Moore kicked the ball straight up into the air 2.4 meters with an initial velocity of 6 meters per second. Determine how long it took for the ball to land on the ground again. So if I kick something up into the air, it's going to go up, it's going to stop, and then it's going to come back down. That's what's going to happen. So there's a couple things I know about this equation. Since this is free fall, right? Since this is free fall on planet Earth, the acceleration is going to be negative 9.8 meters per second squared. All right, I know that because the initial velocity was positive and it was kicked in the upwards direction. So in this case, up is positive and down is negative. And that's why the acceleration is negative 9.8, because the acceleration is always down towards the Earth. Also, there's something special I know about any velocity right at the peak. Right at the peak of the ball being in the air, the velocity is going to be 0. So I know this, I know A, so let's see if I can figure out everything else. So, Mr. Moore kicks a ball straight up in the air, 2.4 meters. So that's my distance, it's 2.4 meters. Right, that's how high it is from here to where the ball reached the maximum height. He gave it an initial velocity of 6 meters per second, so that's the initial velocity. Alright. Now what I can do here is, if I only look at the motion of the ball from when it got kicked to when it... So let's just look at the motion velocity from when it got kicked to when it reached its peak height. Alright, if I do that, then I know that the initial was 6, got 6 meters per second right here. The final velocity is going to be 0 because that's its velocity at the peak height. So in this case, if I'm only looking at it from kick to maximum height, then the final velocity is 0. That's when the ball stops. And look at this. That's a meters per second, not a meters per second squared. Acceleration, since this is free fall, it's negative 9.8 meters per second squared. Okay, and they're asking me to find time. So in this question, look at this. I have 4 variables, and they're asking me to find a 5th. So I can kind of pick which equation I want to use here. I'm not just limited to one. So let's do this equation. So VF equals VI plus AT. VF is going to be 0. The initial velocity was 6. A is negative 9.8. T is unknown. Okay, let's subtract 6 on both sides. Okay, it cancels on the right hand side. I'm going to get negative 6 on the left hand side is equal to negative 9.8 T. Alright, then I can divide each side by negative 9.8. It'll cancel my right hand side, and I'll be left with T is equal to 0.6 seconds. Alright, but now this is just the time it took from when I kicked the ball to when it reached its maximum height. So if I want the total time until it lands again, well, if it took 0.6 seconds to get up, then it's going to take 0.6 seconds to get back down. So my final answer should be 1.2. That's my final answer. But now this is one way to do it. A second way that we could do this is we could use our acceleration question, or acceleration formula. So in this case, acceleration is equal to delta V over T. Acceleration, I know it's supposed to be negative 9.8. Delta V is the final minus the initial. The final was 0. The initial was 6. T is the unknown. So I have negative 9.8 is equal to negative 6 times T. If I multiply each side by T, it'll cancel on my right hand side. I'll be left with T times negative 9.8 equals negative 6. If I want T by itself, I can divide each side by negative 9.8. And in the end, I get T equals negative 6 divided by negative 9.8, which is going to be equal to 0.6. But remember, this is from initial kick to when it reached max height. So if it takes 0.6 seconds to get up, it's going to take 1.2 seconds to fall back down. All right, 2 ways to do that last one. Hope this stuff helped.